In this video, we'll be learning how to find the inverse of a function. So before we can find the inverse of a function, we have to know what inverse functions actually are. So inverse functions are two functions that are reflections of each other over this line of y equals x. So if you look here in each picture, we have the line y equals x. And if you look, if you were to fold along that y equals x line here, you'll notice that the two functions would line up perfectly. They're reflections of each other over that line. So it's a really cool relationship where basically the x and y values get flipped and they're reflected exactly over that y equals x line. So we're going to be finding, if we have one function, essentially finding the other. If we have one function, finding the other by using this fact that they are reflected over the line y equals x. Now finding the inverse of a function is a fairly simple process. The first thing we're going to do is we're going to take our function notation, whether it's, f of x, g of x, h of x, etc. We're going to take our function notation because we know that that's a fancy phrase for saying y, and we're going to rewrite it as y. So that's only if necessary. If it's not written in y equals form, we're going to take function notation and write it into y equals form instead. Then what we're going to do with that function is we're going to switch the x and y values. Because we know it's a reflection over the line y equals x, in order to find the inverse, we're going to switch them. And then we're going to solve that new equation for y by itself. So as we find our inverse functions, that's the process we'll be going through. Switching x and y, and then solving for y. So let's use the process described on the previous slide to find the inverse for the function below. So remember, our first step is to write this into y equals form. So we have y equals 2x plus 3. So that's our first step. Then from there, we're going to switch x and y. This is now x equals 2y plus 3. Now what we're going to do is we're going to solve this equation for y by itself. So this is where we have to use our knowledge of, undoing the order of operations backwards in order to actually solve this equation. So hopefully in your gut, your reaction was to subtract 3 first. So we have x minus 3 is equal to 2y. And then we need to divide both sides by 2. So I end up with y equals, here essentially we have x minus 3 all divided by 2. So that is our inverse function for this original function here. Now what I want to do before we try this some more is I want to actually compare these functions because they're actually pretty similar, which is kind of cool. So here we have y equals 2x plus 3. And then our other function is y equals x minus 3 divided by 2. So what I'm going to look at is if I were to apply the order of operations here on this first function in blue, the order of operations here would be to multiply by 2 and then add 3. So that's what I'm looking at, just this right-hand side of the equation. If I were to look at the order of operations, it'd be multiply by 2, add 3. If I look at this second one here, so here remember that the top of a fraction really has imaginary parentheses. So here we would subtract 3 and then divide by 2 if we apply the order of operations. We have subtraction and division, but that subtraction comes first because of the order of operations. What I think is a really cool relationship between these, though, is if you look very carefully, you'll notice that they contain almost the same operations, they're just opposite. So this one contains, a multiplication of 2, while this one contains a division of 2. This one contains an addition of 3, and this one contains a subtraction of 3. So we have basically the undoing operations in each function. The other thing I notice is that they come in the exact opposite order. So where this one multiplied first and then added, this one subtracted first and then divided. So it's kind of a cool relationship, and you can see how they, as inverses, the reason they're reflected over that line y equals x is because they are the exact opposite function of each other. So let's try a couple more examples here. In this second example, we're going to start by taking y equals 2x to the fourth plus 6 and then switching x and y. So we have x equals 2y to the fourth plus 6. Now our goal here is to get y alone, so we essentially need to undo what is happening to y and rewrite this equation so y is by itself. Now, if you're unsure of what operations to do first, what I suggest is focusing right here on the right-hand side of the equation and thinking about your order of operations, because we know that the order of operations for the functions are pretty similar. They're the opposite operation and they're done in reverse. So here, if I were to apply my order of operations, I would start off with the exponents. So it would be to the power of 4. Then I would multiply it by 2, and then I would add 6. So essentially, as I find my inverse function is going to be all of these happening in reverse. So if I added 6 on this original function, I need to subtract 6, and that needs to come first because it came last before. So we have x minus 6 is equal to 2 times y to the fourth. Now, in order to continue getting y alone, I have to take a look, and I notice that I'm going to divide by 2, and that's because here I multiplied by 2, and in order to have the opposite of that in my inverse function, I'm going to divide each side by 2. So now I have x minus 6 divided by 2 is equal to y to the power of 4. Then, finally, in order to get my y value completely by itself, I need to essentially have the opposite of the power of 4, or I need to undo that power of 4 that is happening to y. Well, to undo a power, we use a root. So we're going to take the fourth root of y to the fourth, which means we also have to take the fourth root of the other side. Now, because I'm taking the fourth root of this even power, remember when we do that, we have to account for the fact that there is a positive and negative version because it is an even power. So here, my final answer is going to be plus or minus the fourth root of x minus 6 over 2 is equal to y. So if I were to write my inverse function, that would just be y equals plus or minus the fourth root x minus 6 over 2. All right, moving on to the next one. So here I notice I have h of x equals 3x minus 4 all over 5. So I'm going to start by switching that to be y equals 3x minus 4 over 5, and then switch my x and y. So I end up with x equals 3y minus 4 all divided by 5. Now, if you're unsure of what to do first, think about your order of operations on this right-hand side of the equation. So we can see a multiplication, a subtraction, and a division. I know that there's essentially parentheses up here. So the first thing that's going to happen in my order of operations would be the multiplication of 3, because it's inside parentheses and it's going to come before the subtraction, also in the parentheses. It will then be a subtraction of 4 and a division of 5. So I need to essentially have those in my inverse function, but they're going to be in the opposite order. So I need to essentially undo that 5 happening to y first. And in order to do that, I'm going to multiply by 5 on each side first. So I end up with 5x is equal to 3y minus 4. So I've taken care of that one. Then the next thing I need to undo is the negative 4. So I'm going to add 4 to each side, because again, remember, the inverse function is essentially what happens in the original function, but the opposite operations and backwards. So here we have 5x plus 4 is equal to 3y. And then we have to do the opposite of multiplication of 3, which is a division of 3. So here we have 5x plus 4 over 3 is equal to y. So our inverse function is just y equals 5x plus 4 all divided by 3. And if you were to check both of these, you would see that the functions that are being performed are the exact opposite and in the opposite order of their original functions, which would result in them reflecting over that line y equals x. So let's try 2 more examples here. So with this function g of x, I'm going to start off by having y equals, that negative out in front, I'm going to add a -1 there so I don't forget that that's a -1. So -1 times x cubed plus 6. So from here, I need to switch x and y, so I have x equals -1 times y cubed plus 6. Now, if I focus on this right-hand side of the equation, I notice that in the order of operations, it would have the cubed first, so we'd have the power of 3 first, then we would multiply y by -1, and then we would add 6. So those are my order of operations that I see, and I know that my inverse function has those same operations, but the opposite of them, and then it has them in the opposite order. So the first thing I'm going to need to undo from y is the plus 6, so I'm going to subtract 6 from each side. So I have x minus 6 is equal to -1 y cubed. Then the next thing I need to do is I need to divide by -1 because I multiplied by -1. So I have x minus 6 divided by -1 equals y to the power of 3. And then to undo that power of 3, I need to take the cubed root of each side to undo a power of 3. Now, because this is an odd power inside of an odd root, I do not need the plus or minus like I did with the power of 4. So here I end up with the cubed root of x minus 6 over -1 is equal to y. So that would be my inverse function. And if you look very, very carefully, you will notice that this function uses the opposite operations of the original function in the opposite order. Now if I look at my last example over here, you'll notice that we need to start by adding in our y. So we have y equals 1/3 x squared minus 8. We then switch x and y, so we have x equals 1/3 y squared minus 8. Now we need to solve this for y, and in order to do that, we need to pay close attention to the order of operations here on the right-hand side. If we look at the order of operations, we'll notice that we have the power of 2 would come first, followed by a multiplication of 1/3, and then followed by a subtraction of 8. So when we write our inverse function, it needs to be the opposite of those functions, and then in the opposite order. So in order to start, we're going to undo that subtraction of 8. So we're going to add 8 to each side. So we have x plus 8 is equal to 1/3 y squared. Now, in order to undo that multiplication of 1/3, I have to divide both sides by 1/3. Now, you can divide both sides by 1/3, or you can remember that dividing by 1/3 is really multiplying by the reciprocal, which is 3/1. So whether you divide by 1/3 or multiply by 3/1, it's the same operation. We've learned that throughout this course. So here what I'm going to do is I'm actually going to multiply both sides by 3. So 3 times 1/3 gives me 1. So that's going to leave me with y squared on the right-hand side. And then here, when I multiply the left-hand side by 3, I need to make sure to multiply both terms by 3. So that includes 3x and then 24. So notice I multiplied both of those by 3. Then from here, we need to undo that squared by square rooting both sides. And since I am square rooting an even power, and that even power is inside of the root, I need to remember to include my plus or minus because it's an even power being undone. So I need to account for both the positive and negative version of the answer that might result. So from here, my inverse is going to be y equals plus or minus the square root of 3x plus 24. And again, you'll notice it uses the opposite of all of these functions here, and then they go in the opposite order.